All right. So, good afternoon, everyone, and welcome to today's webinar from Grid Congestion to Grid Resilience, the role of flexibility enablers. My name is Buse Yıldız. I'm project manager at WIP Renewable Energies, the organizer of EU PVSEC, and I'm also a member of EU PVSEC Executive Committee. It's a pleasure to welcome such a diverse audience and speakers and our moderators here today. In the next slide, you will see our agenda. Today's webinar is jointly organized by EU PVSEC and Energy Storage Europe, bringing together expertise from both the photovoltaic and energy storage sectors. Over the next hour, after a short introduction from each organization, we will hear from our four experts with opportunities to ask questions throughout the session. Before we begin, I would like to briefly introduce the organizations behind this webinar. EU PVSEC is the world's leading conference and exhibition dedicated to PV research, technologies, and applications. For more than 40 years, it has served as the meeting point for the global PV community, bringing together researchers, industry representatives, policymakers to exchange knowledge and drive innovation. Energy Storage Europe is the leading European association representing the energy storage sector. With members spanning the entire storage value chain, the association plays a key role in promoting energy storage as an essential component of Europe's clean energy transition. Well, this collaboration is a natural one, as solar power and energy storage are no longer separate conversations. As renewable energy deployment continues to grow, the success of one increasingly depends on the other. Throughout our joint activities, we aim to strengthen the links between stakeholders from both sectors, encourage knowledge exchange, and create a platform for discussing shared challenges and opportunities. This webinar is part of our ongoing collaboration, and together we want to accelerate the energy transition across Europe. This brings us to the central topic of today's discussion. The rapid and positive growth of renewable energy sources, particularly solar PV, is transforming how electricity is generated and consumed. Considering Europe's electricity grids were originally designed for large and centralized power generation, across many European countries, grid congestion is becoming a significant bottleneck. On the other hand, this challenge presents a major opportunity. It's proven that flexibility solutions such as energy storage can improve the grid resilience and unlock more PV capacity without major grid expansion. Today's speakers will provide valuable insights into how these solutions are really already being developed or deployed and what they could mean for the future of Europe's energy system. With that, I would like to thank you all for joining the session, and I hand over to Dr. Robert Kenny for the introduction of EU PVSEC. Enjoy the webinar.
Wow, nice photo. Bit old, perhaps. Anyway, no, thanks a lot, Buse. I'm really delighted to be here. I mean, I have to say, I first went to the EU PVSEC conference about 25 years ago as a kind of junior researcher, and we had a dream, you know, to make solar energy something that could solve lots of problems around the world, energy poverty, the climate change, which we see every year getting stronger and stronger, make it cheap and available. And we've actually reached that now. It's been absolutely incredible, the progress in this time. And but now we've reached another barrier, which is now actually getting it out there on the large scale. And I think we can do it. And we'll learn a little bit more today, I hope, in this webinar about how we're going to do it. So since that time, in the last few years, I've been the technical program chair of the conference, which I'm absolutely really delighted to do. I'm really proud to do that for the last few years. So what I just want to do now is just, for those of you not familiar with the EU PVSEC conference, just give you a really quick background of what we do. Buse has already said quite a bit about it. So I'll just highlight a few things. So I just make it clear that the conference spans the entire photovoltaic value chain. So we're going from fundamental science, materials, concepts, and we go right to cells, modules, applications, deployment. Obviously, energy storage is now an increasing area of interest and importance, right through to policies, markets, economics, and also the social aspects as well, which are also very important. And sustainability, I did mention another very, very important aspect that we all have to bear in mind all the time. So we cover everything. It's a great place to meet, network, learn about what's happening over an entire week, what's happening in the field, your own area of expertise, plus learn a little bit about what's happening in related areas. So the program, we break it down into 5 basic topics. So we start, the first one is silicon materials and cells. The second one is perovskites and other thin film technologies, the growing area of tandems. And then also we have as subtopics working on new concepts. The third topic is basically everything to do with photovoltaic modules. We look at design, sustainability, manufacturing, performance, lifetime, questions like that for modules. And then moving on to the fourth topic, we have the systems design, operation, and a whole range of applications. So growing all the time. Okay, we've got building integrated PV, rooftop floating PV, agri PV, you name it. There's a whole range of applications out there growing all the time. It's all very exciting. And then we have the fifth topic, which is called photovoltaics in the energy transition. So here we're looking at, okay, all the issues through deployment, integrating into the grid. Again, energy storage is a massive area there to get us over this next bottleneck in the deployment of massive scale renewable energy. We look at sustainability questions, a very big topic about how you make sure that the PV modules that we install are going to be fully sustainable and recyclable. For example, that's very, very important that we keep everything green and clean. But then there's also socioeconomic questions, social acceptance of the modules. As you probably have heard, sometimes you get resistance to putting modules in certain places. We have to be careful of that. Make sure we do that in the right way, that everybody wins in this new energy system we're trying to build. So what we've learned in the last few episodes of the conference, and we'll be hearing about in the next one, which will be in September, that okay, becoming ever more important is hybrid PV systems. Flexibility enablers and energy storage becoming ever more important. The question of grid integration and stability of the grid. Manufacturing, a very sensitive topic about where modules are manufactured. The question of securing your supply chain, your energy resilience, all those kind of questions are very important. And of course, as I mentioned a minute ago, also sustainability is really critical, that we can build out this system in a sustainable way. And I guess that'll also apply to the storage as well, and not just the PV part of our future system. And also, I think it's really worthy of note that we've also noticed that AI techniques in general, and I'm not talking about large language models here, but AI in general is also becoming very, very important in all of these topics, from the design right through to the operation and maintenance, for example, becoming very, very, very important. And then very quickly, I would emphasize that we have some plenary sessions during the week, which are a great way to get an overview of the field and see what's happening, all the different topics. So we have the first one on the Monday morning, which is PV and the energy system. And that, I suppose, is particularly relevant to this energy storage question. But we have other ones which will deal with a whole range of different topics as well. It's a great way to learn about what are the latest developments in these different fields. And a great panel discussion is planned for the Monday morning, which has a working title at the moment of Grid Congestion Management and the Perspective of the Netherlands. And then I would just conclude by saying I would look forward to seeing you in Rotterdam in September, if you can make it for this great, exciting week at our conference. So I'll hand back to the moderator. Thanks a lot.
Thank you very much, Robert. And indeed, I am the moderator of today's webinar. My name is Daniel Wig. I work for Energy Storage Europe as a senior policy officer. Now, just a quick word about our association. We are Brussels-based, and we have more than 70 members. And when I started working here 2 years ago, I remember that we had around 40, almost 50 members, but we have grown quite rapidly in the recent years. And I think this shows the relevance of energy storage across Europe and across the continent. And in our work, of course, we try to shape the discussions on energy storage and influence how regulations are made, and be really vocal about how energy storage can provide flexibility and basically be grid friendly. And so concerning this webinar, we will talk a lot about how PV and storage can work hand in hand in providing flexibility. Some of you may have seen that a couple of weeks ago in May, we had in the wholesale electricity market -400, -500 euros for 1 megawatt hour. These were the day-ahead electricity market prices. So there is a clear need for flexibility, and this is why our sector is luckily growing quite rapidly. And I do believe that this will remain to be the case in the foreseeable future as well. And lastly, before going to the first panelist, I would also like to highlight our own conference, which will take place in October, where many of the elements that will be discussed in this webinar today will also shape our own conference in the beginning of October in Brussels. And so now I would like to go to the first panelist, and please feel free to pose your questions in the Q&A in a written form, and I will ask the questions at the end of this webinar. So firstly, all the way from Cyprus, I would like to introduce Venizelos Eftimiou. He works at the University of Cyprus, and he has a long-standing experience on PV and how solar influences the electricity grid. So please, Mr. Eftimiou, the floor is yours.
Thank you very much. Good afternoon, everybody. Thank you very much, Daniel, for introducing storage. Can I have the slides, please? Yes, obviously, the green, reliable future of the grid that we are planning, I can assure you, is coming. Next slide, please. Obviously, we have gone through an important problem recently in Spain, Portugal. Already Daniel has indicated problems that we are facing with negative prices and problems, stability problems on the network that we have experienced in Portugal and Spain. These are problems because we didn't see the contribution of batteries really going hand in hand with penetration of renewables to the degree required is something that was missing in the network. Next slide, please. And so because it was missing, the system went unstable and we have lost all the supply to the network. Next slide, please. But of course, the quality of supply, the system as it evolves, we see how important batteries are contributing to the network, because as we see on the right is how the conventional generator is giving the daily operation to the system. And we see the differences between the actual needs and the actual given, while on the left, where the battery is controlling what is given, you see how it closely follows the requirement, which shows the quality response of battery systems with to the needs of the system. Next slide, please. So all this situation is changing. The system is being transformed, but the grid is still the backbone. And we see how the system, with the demand side participation growing, and we see how PV integration and wind is growing in the system. But at the same time, we are seeing a flexibility coming onto the system greatly, that is supporting and replacing peaker plants at times that are valuable to the system. And so we see electricity storage, we see EV charging, and we see active network management that is critically important of how these systems respond to the requirements of the network. Next slide, please. And the embedded flexibility on the grid is important, highly important. And we can see a list of flexibilities that are already in the system. But we need to use this flexibility in both directions, both in capacity, but also in energy direction. And so energy optimization shifts consumption, production, and storage to align with low-cost periods, ensuring efficient energy use, and grid capacity optimization schedules flexible loads to reduce congestion, minimizing the need of costly infrastructure expansion and enhancing system efficiency. Next slide, please. But we see flexibility coming in many directions and in all areas of the grid, and we need to utilize it. And the segmentation of flexibility, as we see it, it can serve to support behind the meter, in other words, where we are in buildings, where it can offer valuable services through the in buildings management systems, valuable services. It can offer to the connected system, the grid, the distribution infrastructure, valuable services through these services that I list here, but also all these valuable ancillary services, how the system responds, how the system supports, how the system behaves, is all the facilities that we see here as flexibilities serving the system. Next slide, please. And of course, as we grow in these technologies, it's critically important to understand that power electronics are with us. And we see that storage, together with power electronics, can deliver these advanced features of controllers that can deliver the fast frequency response in milliseconds. And it can stabilize the power grids. It can shift from standard grid following, as we call them, to grid forming capabilities. And these controllers enable much faster and smoother active power injections without grid disturbances. And all this, we have here five different capabilities, services that they offer that are highly valuable to how the system can behave and be responsive to the requirements of the grid. And here we see how grid forming capabilities can act as virtual synchronous machines, synthetic inertia, and respond to the rate of change of frequency and be supportive to the network. It can also adjust as an adjusting controller, responding to the rate of frequency. It can support how the rate of change is affecting the system, and hence avoid these problems that under frequency load shedding offers. And tightening frequency deadband also gives all this quality control that we see, and steeper dynamic droop characteristics enable more aggressive yet stable responses to severe grid and events, and adjusting the virtual impedance of grid forming controllers limits the sudden voltage drop that a weakened fast frequency response needs in order to offer services to the system. Next slide, please. And all this together, and all this adding the services that we see, if we combine them in a collective way and giving them a combined effect through, let's say, the high power and the high energy in a combination service to the system, through the advanced features of energy management systems, we can achieve a lot better results out of this controllability of the network. Next slide, please. And this in replacing the traditional mechanical inertia that we have been relying on for giving secure operation of the system, we now have all this that I have described now, the synchronous, the virtual machines, the fast frequency response, and all the services that I have described, we do give them through through the photovoltaics and the controllers and the storage systems, the flexibilities that we offer to the system. Next slide, please. And of course, as I indicated already, through a combination of flexibilities, we can achieve a lot better all the requirements of the network. And so in this example here, when we combine the services of e-mobility, of DC systems, of storage in a combination together, we can achieve the best response in nadir. In other words, how deep the voltage will go, how the rate of change of frequency will respond as low as possible. The frequency recovery time is going to be as fast as required, and the energy used for fast frequency response much improved. Next slide, please. And all these services that are much faster through good quantities of storage penetrating the system, we can stabilize the market and we can offer real value for money because they replace the peak of the system. As we see here in Australia, in April 2026, they have replaced all the peak in gas. And really today, storage is operating most of the time of the day in when it matters. Thank you very much. Next slide, I think, is a finishing slide.
Thank you very much for this very, very interesting and detailed presentation. I just have one quick question, if possible. So you work in Cyprus, and I think here in continental Europe, the capabilities and the need of energy storage in an island is different than, let's say, in Belgium, where I live. Could you maybe share your on-the-ground experience in Cyprus? How is that different than here in continental Europe?
Yeah, the question is very good, but the answer is not so good, because in Cyprus, still, we didn't invest in storage, unfortunately. And we are throwing every day 50 to 60% of valuable renewable energy because we cannot cope with it, because we cannot operate the system safely. And all that energy is wasted, and we are paying CO2 emissions highly. And instead, if we have followed the route of Australia that has 2.14 gigawatt hours per million inhabitants. In other words, if we had in Cyprus 2.14 gigawatt hours that we are 1 million, all these wouldn't have been thrown away. We wouldn't have been paying all these CO2 emissions, and the system would have been a lot much controllable.
Yeah, it's very interesting what you say, and yeah, I'm surprised that there are no batteries or grid-scale batteries in Cyprus, because I know that here in Europe, Ireland is very advanced as well, and as you mentioned, Australia, similarly, an island, they are very well advanced in the integration of storage. So I hope that in Cyprus that will be the case very soon.
I'm not surprised that you are surprised. We are surprised, but it is a policy decision. Unfortunately, we didn't invest as we should have been.
Yes. Not yet, but here in this webinar, we try to really make storage even more visible. And now I will hand the floor to our next speaker, who is a representative of Energy Dome, a company which is a member of Energy Storage Europe, where I work at. And they have a very interesting technology, because when we talk about energy storage today, most people think about batteries, but Energy Dome works with a different kind of technology. So please, Jesse, I give you the floor now.
Thank you, Daniel. I think we can advance to the first slide. Good afternoon, everyone. My name is Jessie Shulashay. I'm the Director of Regulatory and Policy at Energy Dome. Thank you to the webinar organizers and moderators for inviting Energy Dome to participate this morning. We are very pleased to be here and excited to talk about the role of long duration storage to bolster grid flexibility and grid resilience in the transition to a decarbonized grid future. I want to give a quick overview of Energy Dome and long duration storage before jumping into the presentation, just to level set. So Energy Dome is an Italian-based company. As Daniel said, we're members of Energy Storage Europe. We've been around since 2020, and we work in the energy storage space of 8 to 24 hours. We can stay on the next slide. That's okay. Thank you. Yeah, we can advance. Thank you. So long duration storage, which is the space that we're working in, is typically anything above 8 or 10 hours of duration. We are, it's a grid connected resource, and right now there are numerous technologies in the long duration energy storage field. So that's a little bit different than what we see in the shorter duration field, where it's mostly lithium ion batteries. At this duration, you do see lithium ion batteries operating in the 8 to 10 hour space. You also have our technology and a number of other technologies that are sort of all in the space trying to, solve various grid challenges. So as an intro to Energy Dome, we are we've been operational since 2022. So our technology has been deployed in Sardinia, Italy, since 2022 and have been operating since then. Then in 2025, we established our first of a kind 20 megawatt plant that is fully grid connected. It's under a tolling agreement with ENGIE. And then in the US, we have a signed contract with Alliant Energy, which is a generation utility here. We're working on a project with NTPC in India, and then we have a robust commercial pipeline in the US, in Europe, and then globally as well. Generally, our resource and long duration resources as well, but I'll talk to specifically ours, really works in the capacity of being a base load, reliability, flexibility resource. And so, we work extremely complementary to your shorter duration battery storage resources, where, those resources are able to really bring down peak demand and respond very quickly to energy arbitrage. You talked about sort of this negative pricing that was experienced recently. What long duration energy storage is able to do is sort of work from the bottom up and replace that baseload thermal fossil capacity, which really enables a fully decarbonized grid that is able to integrate very high penetrations of renewable energy. Oftentimes, we are working with off-takers, utilities, customers that are looking for 100% decarbonized grid or even hourly matching. And that really is where long duration storage can sort of bring that equation into light and make that that value proposition really make sense. In addition, our resource, which I will describe how it works in a moment here, does have rotating equipment, rotating parts. We have compressors, turbines, very similar to your traditional gas resources. And so what that means is that we, bring the same traditional reliability services that the power system has relied on for decades. We bring physical inertia and stability services, frequency reserves, operating reserves, voltage and reactive power services, black start, very similar to the suite of services that are needed for the grid, to function today. And so we're really able to replace the thermal from that very baseload grid stability perspective as well. We are also, alongside most other storage resources, able to reduce curtailment of clean energy generation. Long duration storage can be utilized as a transmission asset in the event of high congestion. We can, store and dispatch that later. And then overall kind of lower system costs and stabilizes energy prices due to the fact that we're able to ensure that the grid is being more fully utilized and all of the power that's being generated, especially, to offset sort of the typical curve we see of PV is able to be dispatched when it's needed, even if it's not, right when it's being generated. About our technology, We believe that we're the only, non-lithium commercially deployed long-duration energy storage that is currently active on the grid and ready for scale. What I mean by ready for scale is that we are, highly efficient. We have 72% round-trip efficiency, comprised of off-the-shelf materials. So our innovation is really how existing materials can come together in a storage asset and not an entirely new, risky, process or anything like that. And we have no reliance on critical materials from conflict regions or anything like that. Typically, we can deploy our resource in 18 to 24 months. Our first of a kind plant we deployed right around 16 months. And so, we really are excited about, as we scale to larger than 20 megawatts, being able to take lessons learned from that plant and also utilize economies of scale to meet the really impending grid needs that we're seeing globally to sort of help with the energy transition and make sure that our resource is part of the solution. We are able to do this because we have identical engineering and construction between subsequent plants, which enables transfer of lessons learned. We're not making one-off decisions for every installation. We're really standardized and making sure that we can deliver based on timelines and based on grid need and kind of working on those programs. We can advance to the next slide. So the way we work, our innovation we are a thermomechanical long-duration energy storage resource, which means that we're using the same pipes, pumps, heat exchangers, compressors, turbines. It's a steam turbine. We're not using a gas turbine. That is very natural to the utility industry and the energy industry. If we can go back to the charge slide, that would be very helpful. Thank you. So on our charge mode, we're going to go back 2 slides. Thank you very much. On our charge mode, so we use carbon dioxide as our working fluid, which means that we are using non-supercritical, more or less food grade carbon dioxide, which in the charge phase starts as a gas, which we withdraw from an atmospheric gas holder, the dome. That's why we're called energy dome, which we then compress through a compressor. And then, which is driven by a motor, which is drawing electricity from the grid. The heat generated from this compression, as we're going from, an ambient pressure temperature gas to a higher pressure temperature gas, we store that heat in a thermal energy storage system while this carbon dioxide is passed through a heat exchanger and liquefied and ultimately stored in vessels under pressure at ambient temperature. This process has no emissions and no ongoing water usage. Like I had said before, 8+ hours of storage duration, around 73% net round trip efficiency. We charge directly from the transmission system. We can be co-located with clean energy resources, but that is not required. You can speak to sort of nodal needs, but we don't need to be, behind the meter or physically co-located with a clean energy asset for the benefits to exist. And then we're a fully closed loop system. Now we can move to the discharge phase. On the next slide, thank you. In discharge mode, we reverse the process. The CO2 that was stored as a liquid is passed through this heat exchanger and now evaporated to a low pressure gas. It then is passed through that thermal energy storage unit, which was storing the heat from compression. It now becomes a high pressure, high temperature gas. We can still stay on that discharge slide if possible. Thank you. And then after that high pressure, high temperature gas is passed through a turbine, and the physical rotation of the turbine expands it into a ambient pressure temperature gas. And then the rotational energy is transformed into electricity, which is passed to the grid. And so again, we discharge directly into the bulk transmission system. We can be co-located with, a large industrial load. Again, that's not required, but we are sort of able to serve the grid. We're set up for daily cycling. We don't have any augmentation needs over time. The RT does not decrease. And so this is generally how our system works. We can go to the next slide. And being mindful of time, I think this will more or less conclude the presentation, but just to sort of touch on, again, our asset, along with many other long duration assets, is really able to provide that base load power that is able to, expedite the retirement of thermal generation while welcoming PV and other clean energy resources to the grid without compromising grid reliability, grid resilience, or electricity prices. So yeah, I will pause here. Thank you very much.
Thanks so much for introducing this technology, because I think long duration storage has become very important in Europe. And so my quick question for you is that I hear a lot about that there is some differences in Europe and in the EU when deploying short duration versus long duration storage, that there are maybe some market or regulatory challenges concerning this. What challenges do you see, and what would you recommend the European Commission to implement or change?
That is a big question. I appreciate it, and we'll try to take that on, in a succinct way. Yes, we see this in Europe, but I also, I think you can probably tell by my accent, I sit in the US. This is happening in the US as well, so it's not, it's not just sort of one place learning. I think what I would mostly convey is that, to date, markets have been set up to be competitive, which is really good. But sometimes what that can cause is bias toward incumbent resources, just based on the language of an auction or a procurement, can sort of preclude resources that don't fit within the box of the expected technologies from being eligible. And that's not something we really want to see. So, it can range from a number of different things, right? Sometimes we're seeing evaluation is just on a dollar per megawatt basis. That can be really challenging when Energy Dome is bringing, or long duration storage, at 100 megawatt, 10-hour system versus a 100 megawatt, 2-hour system. There's going to be different economics within that. And if we're not really able to look at some of the grid services, some of the megawatt hour pricing, some of the round trip efficiency conversations, that can really disqualify our technology before we're really able to be part of it. And so, what we sometimes recommend is taking a more holistic approach to just pricing. You're looking at, decarbonization potential, grid reliability potential, cost, of course, development performance, things like that. Other things we look at can be more technical in nature. Sometimes we'll want to, an auction or a procurement will want to see we can get all the way down to sort of zero, even with no load, which best lithium can do, but we have some auxiliary load just to sort of keep ourselves running. So you have to think about, do we really need that, or kind of can we be more accommodating to sort of an all source resource mix? And so I just encourage grid planners and those running procurements to really think about, if we're trying to maximize for a diverse grid, which will have diverse resources on it, how do we make an auction or a procurement as inclusive as possible, and then be able to, rank resources based on what they're bringing to the grid, as well as cost, to make sure that we're thinking about the affordability perspective as well. Thank you, Daniel.
Thanks for the answer. And of course, if I would like to tell the audience that we recently published a position paper on long duration storage. So please feel free to visit our webpage and learn more about long duration storage, because it is becoming increasingly more important for the security of our grid. And now I would like to go to our next speaker, who lives in Germany and is a researcher, and she will talk a bit about how PV and storage can provide flexibility to the grid. So please, Dr. Svetlana Merzadanova, I give the floor to you.
Thank you very much, Daniel, for the kind introduction. And good afternoon, everyone. It's my pleasure to be here and to present our recent work on outlook into PV growth beyond grid flexibility, which can be realized via integration with storage and fuels. The next slide. So we can go to the next slide, where we all agree that PV is a success story. And if we would like that PV continue to be a success story, we have to take a look at the numbers. And on the next slide, I show the electric power installed and planned in Germany, because I live in Germany, so the study is done for Germany. So we have installed PV capacity grows persistently faster than forecasted. And we show here the development from 2012 and predictions to 2040. And you can see already that at 2024 in Germany, the nominal PV capacity exceeds the maximum grid power capacity. But interestingly, from the same time, the maximum power to grid, the maximum PV to grid power, this is the red curve, already starts to deviate. And the reason is that we already have zero and negative electricity prices at the peak PV generation. And you can see here in the next years, you see this gray huge area. It will be a big market of excess PV energy, and every additional gigawatt of PV capacity will have a lower chance for utilization if you continue to install without thinking of storage. And handling excess power requires a serious grid upgrades, flexibility, and considerable redundancy. But of course, usually if the people, the grid will, of course, will increase and will be updated. But when we talk about this, it's always related to the demand. And of course, the demand and grid, they are always connected, and these are the argument for the growing of the grid. And it will be quite negative point if we upgrade the grid because of the PV and wind and their instability. So you can go for the next slide. And the picture change if we plot the same data, the installed power, as a function of the energy, which is yearly energy in terawatt-hours, which is delivered to the grid. Then we see with the red star that we are, due to the lower capacity of the PV, we are far away in year 2024 to that what are the possibilities. And therefore, I don't need to convince you that PV needs a storage, so we can go to the next slide. And not only storage, but we have to more deeply think and ask our questions. Can you go for the next slide? And we have to ask ourselves what is the ideal storage and how we can turn PV into stable power source, meeting the demand 24/7 and 365 days of the years. And we have to look and request the question in perspective of the time, and also the scale. What kind of scale of storage capacity we need to match the scale of the PV power and energy. And we also can think and rethink the question where to place the storage in order to minimize the impact of the grid. And by this, I will go to the next part of my presentation, where the aspect of the time will be addressed. So you will see the typical carpet plot of PV power delivered in Germany, in the German grid for the year. I take always the year 2024, where we for the first time saw that we reach with the peak power the limit of the grid. And if we choose some day in the summer and then we project it to the 400 gigawatt, which is planned and forecasted for 2040. You can see on the right hand side at the peak for the summer day, and also on a winter day, and plot it together with the PV share target. And you can see that we have around 50 gigawatt for the daily storage, which can be covered with technology which exists like the batteries, but you have 100 gigawatt for the long-term storage, which is now for the developments. So we can go on the next slide, and the technologies which can cover the daily storage and the long-term storage are existing. With the long-term storage, we have electrochemical conversion driven by PV, excess PV, where we can convert the electrical energy to molecules, and some chemicals we can use by demand later on between the seasons. And we have to also think about the scale, and this will be shown on the next slide, where we look deeper in the data and present here the dependence between the annual energy and the annual PV share in Germany as a function of the installed PV capacity in the x-axis, together with the grid demand. And then we can see that we have two regimes, grid absorptive and PV dominated. And now in nowadays, the yellow points are real data which we take, and we project it in order to obtain the maximum potential of the PV, which we will increase linearly with the installed capacity. But we see that we are now on the transition between the grid absorptive. We are still okay. In Germany, we are around 17% of PV share. But we will be soon, or we are already in the PV dominated regime. And we done two calculations where we assume that we continue business as usual. We don't think about storage solution, and we continue to install PV and grow. So by this, you can see the red curve where it's indicated no storage. And you can see that already by 120 installed PV capacity, which is around 20% of PV share, we are a little bit now coming closer to this point. We will have declination, and we will not grow because the losses due to negative prices and containment will be huge, and we will have also some social justification in order to continue to grow with the PV. And then we play with the second case when we include 2 hours battery to some installation. And then we saw that we can significantly, this is the blue curve, we can reach 30% share with 2 hours battery. And I will also mention some numbers to imagine the scale, which you cannot read from this figure. But for example, for the case in 2040, when we expect to have 400 gigawatt peak installed PV capacity, then for the short-term storage, we need to shift up to 0.0 terawatt energy capacities during the day. And if we are talking about long-term storage, we have to shift up to 80 terawatt hours energy during the seasons. And you see the dimensions and differences between these numbers. And then I come to the third aspect, which will be shown on the next slide. And this is the placement of the storage, because this play also very important role. Storage can be placed at different distances and power delivery stages, which you can see here. So we can place PV like usually do it now, farther from the PV module, which is shown on the left-hand side. And then we have storage at the middle voltage and high voltage grid. But of course, we can go further and shorten the distance between the PV installation and modules and the grid, and go to the low voltage grid. and then we will get relaxed and requirements for the grid development and flexibility. So we can also go more further. On the next slide, when we can have storage at the AC or the DC part, we can now come back because I think we were too faster with the slides.
Sorry, Catalina, sorry, to be mindful of the time because we have only 10 minutes left of this webinar and we still have a colleague who will present.
So I finished, but
give a conclusion.
To our opinion, we have to rethink and bring the storage close to the PV, bring communities. This is the most challenging solution, and we have to work on this. So you can go on the next slides. On the next one, where we have a solution of a hybrid PV battery electrochemistry concept, where the PV and the battery are together in a module and connected in parallel to electrolyzer, when we can have an CO2 from the air and capture it. The technologies are existing, and we have a beneficiary from the battery, which allowed us to significantly reduce the capacity of the electrolyzer and their synergies. If you would like to learn a little bit more about this topic, we are at PVSEC, the conference presented from Robert in September in Rotterdam, and we are looking forward.
Thank you so much. And I would also like to highlight that if you would like to learn more, then this presentation will be available online along with the recording. So for more details,
I would like to say something more. Yes. Second. I would like to thank all my people and especially Sasha, because I have the honor here to present Sasha Stakov's work and all group. And yeah, thank you.
Fantastic. Thank you. And thank you so much for this very detailed and very interesting presentation. And I really advise everyone to download this presentation after the webinar. And now our last speaker is from a Belgian company, B-Store. His name is Kevin Millis, and he works very much with the topic of regulation of energy storage in Belgium and with regards to the EU. So now I'm very happy to give the floor to Kevin.
Thank you, Daniel, for the introduction, and thank you to the organizers for having me. Very happy to be here. I see that I have, according to the original time, -2 minutes for my presentation, so I'll try to keep it as short as possible to save some time for questions. So let's dive right into it. And so on the next slide, to briefly set the scene a bit, but I think it's a point that's already been made by a number of the previous panelists. So, but we really don't have an excess renewable generation problem at this point, but it's much more a grid usage problem that we face here in Europe, where the rapid growth in PV is just one of the drivers, alongside with the fact that grid capacity expansion is not keeping pace, which leads to congestions becoming more structural, which means that curtailment and collection delays are increasing. So the rest of my talk will be mainly congestion focused. And so if we move on a bit, if we talk about congestion, I think it's very important to underline that at this point we see congestion is no longer a local issue. In the past, it used to be an isolated bottleneck where at a certain point there was a congestion issue. However, now we see that congestion is really becoming a system-wide constraint. Again, it's driven by a few things, right? You see there's increased electrification of both supply and demand. What also is in question is how do we actually utilize our existing capacity? Are we using that in the right way? But again, it's clear, I think it's clear for everyone who has a project or is trying to connect something that the grid reinforcement cannot keep pace with the current system needs, which leads to growing and longer connection queues. So I think the challenge really is system optimization and not just expansion. And then on my next slide, I'd like to talk a bit about how can storage help with this challenge. So basically, as mentioned before me by the other panelists, flexibility and storage which provides this flexibility has really become a necessity, especially as storage directly allows to address these congestion-related issues. Storage can shift energy in time, which reduces the peak. It can also absorb excess generation, which limits the curtailment of those renewables. It provides local balancing, which relieves local grid constraints. So it really allows to maximize the flow of the existing grid capacity. And yeah, let's move to the next slide. So basically, storage should really be seen as a system asset, in the sense that storage is much more than just a market participant or just more than something that provides gainful employment for me, but it is really something that adds value to the system. It helps with congestion mitigation, it helps with grid optimization, it helps with renewable integration, and through arbitrage, it also actually helps to reduce the wholesale prices that all grid users are exposed to. So really, storage should really be seen as grid enabling infrastructure. So based on these virtues of storage, over the next 3 slides, I'd like to briefly hit on a few points that I think we need to change. The first one of those is congestion management and queue management. Right now, the real congestion impact of a new grid user is still uncertain. It's of course hard to estimate, but if we underestimate it, it will lead to real congestion issues because the grid can't actually handle what's there. But at the same time, if we overestimate this impact, it will lead to unnecessary delays and very long connection queues, and also overinvestment as the grid is expanded for users that aren't really there. So that really shows that we need to have realistic modeling of congestion impact. Then the next thing that I think deserves a bit of attention are the flexible connection frameworks. So they're nice in the sense that they facilitate new connections even in the face of congestion problems. However, the rules should be clear and non-discriminatory. And very important for storage and flexibility, the rules should really ensure that flexibility remains bankable and investable. Third important ask, so to speak, is I'd like to touch upon, sometimes you hear this discussion that, yeah, really flexibility really begins to compete with capacity expansion, so that non-wire solutions are competing with wire solutions. I think that's a bit wrong, in the sense that if there's a congestion tomorrow that you wish to address today, the only option is flexibility. Because if you want to address a congestion of tomorrow with a wire-based solution, you needed to make the decision and the investment 5 to 10 years ago. So right now, in the short term, flexibility is all we have. So maybe also on my next slide, I'd like to briefly hit on the point that really, to get more storage and more flexibility in the system, it's not a technical problem. Technical feasibility is done. It's just we really need to have the right framework to get everything in place. In the interest of time, I'm not going too much into details. Maybe on my next slide, really, so my key message to all of you here today is: do not block the solution, do not block flexibility, do not block the integration of storage, as storage can really help drive down costs for other grid users. Also, if storage is handled well and is modeled well, it can really also increase the hosting capacity for other grid users, which leads to the risk of really blocking what solved the problem. So then, finally, some parting words on my final slide. One thing I haven't touched upon yet, I really think in moving forward towards a more resilient system, we as an entire community really need to address the way in which the transmission system operators are remunerated for the costs they make. Currently, it's usually regulated asset base plus, which means they are paid back for the investment costs they make. As long as we continue to do that, there's a vested interest for TSOs to invest in additional wire solutions. If we want them to adopt flexibility, we really need to look at operating costs. And again, flexibility is really an immediate lever which can help us address congestion issues already tomorrow. So yeah, that's everything in a nutshell. I went as fast as possible while still remaining clear. So thank you, Daniel, and thank you, everyone. And well, yeah, back to you, Daniel.
Yes, thank you very much. And I see the time that we only have 1 minute left, so we might go a bit over time, because I have a question to you, Kevin. And this is very much with regards to the discussions that we have in Brussels and also in the member states about how regulations should change. And you've said what needs to be changed. But then my question is, should it be a top-down approach coming from Brussels, or should the member states still have their responsibility with regards to grid connections and queue management, as you mentioned? And please, if you can answer very quickly, because we are over time already.
Yeah, thank you, Daniel. Very interesting question. Maybe a bit of a easy answer, but I think the right answer is somewhere in the middle. In the sense, we need an amount of top-down to ensure a certain amount of standardization, as I mean, the marketplace is becoming one across Europe. So rules for connections should also not discriminate between different member states. But at the same time, I also think that there needs to be some latitude for, let's say, local differences, because everyone's grid is different, and there are certain, perhaps, a bit of historical baggage that you still have, which needs to be taken into account.
Yes, thank you very much. Yeah, the balanced approach, of course, is very important. So yeah, we need to respect the different type of situations that member states find themselves in as well, and not everything should come from the top, from the Commission. I see that we are now 1 minute over, so I will just conclude this webinar now. But please, to the audience, feel free to reach out directly to all the speakers. You see their names on this slide, and I'm sure that they will be very, very happy to discuss this with you, the different elements that were discussed today in this webinar. And I found it extremely interesting, today's discussion, because on the one hand, we had some very technical and detailed information about co-location and how solar and PV can work hand in hand. And on the other hand, in order to use this asset, we need regulations which are fit for purpose, both in the member states and from the European Commission. And here at Energy Storage Europe, we are delighted to help shape these discussions. And lastly, I would now close this webinar by handing the floor over to Robert Kenny.
Thanks a lot, Daniel, and thanks to all of the speakers. It was really fast and furious today. I just wanted to note that I see we do have a few questions and comments that were inside the chat, and so I'd apologize to somebody put a question that hasn't got an answer at this time. But I think, as Daniel mentioned, please feel free to contact any of the participants directly, and they will be really happy to answer questions. So just to say that we're not. We appreciate your feedback, and we don't want to just leave that just hang there unsaid. So just very quickly, I'll just conclude then, just to remind you about these two upcoming conferences. We've got in no particular order, maybe order by date, the EU PVSEC conference, which is going to take place on 14th to 18th of September in Rotterdam. It's a week-long conference. Late abstracts are still being accepted. So if you do have some work you'd like to present at the conference, please feel free to do so. And also we have some early bird registration open. And then we have in October, 6th to 8th October, we have the Energy Storage Europe conference taking place in Brussels. And again, here there is an early bird registration open now. And I would just conclude by saying I would really look forward to seeing as many of you as possible at both of these really interesting events. So thank you very much for taking part.
Thank you very much. And with this, I will then close this webinar. Thank you so much for your participation. And indeed, I saw the questions in the chat, but unfortunately, because of lack of time, my recommendation is really to reach out to us either through LinkedIn. You can find us online. So thank you very much for listening to us, and thank you for the panelists as well. And I hope to see you soon. Have a good evening. Thank you.
Thank you.